Hi, I'm Dr. Craig Anderson. I'm a senior lecturer in statistics at the University of Glasgow, and I'm here to talk to you about how statistics can be used in the real world, and specifically how it's used to monitor air quality across Scotland. I originally came to the University of Glasgow as a student to study mathematics, but also picked statistics as my second subject, and over time I realised that that was where my real passion lay, and I ended up completing a BSc in statistics before actually going on to complete my PhD in statistics here at the University of Glasgow. Before I came to the university, I didn't actually know a great deal about statistics or what it was, and many of you may also be thinking the same thing. But over time, I realised that it's a really diverse subject which allows you a wide range of opportunities to do a lot of different things as you develop through your degree. So what is statistics? Well, statistics is the science of uncertainty and understanding data. And data is just another word for information. And on a daily basis, information is being collected about more or less any topic you can think about. And statistics is all about using and processing this data in such a way that we can have a stronger and greater understanding about what's going on in the world. Data is really found everywhere. Anytime you use an app on your phone, buy anything using your debit card, or use any sort of internet-connected device, data is being collected about you. Companies try to use this data to help understand you as a person. But as well as for these uses, data can also be used for a lot of good in the world. And what I'm going to talk about is some work that I've been doing on environmental statistics, and specifically how we can use data to help us understand the air quality around Scotland. So why does air quality matter? Well, the World Health Organization have a set of guidelines which govern a safe air quality, and only 1 person in 10 in the whole world lived in a city that complies with these World Health Organization guidelines. The World Health Organization also estimate that 1 in 9 deaths worldwide are due to pollution. And outdoor air pollution causes around 3 million premature deaths per year. The Royal College of Physicians puts this figure for the UK at around 40,000 deaths per year. And the total annual cost to the UK economy could be as much as £54 billion per year as a direct result of air pollution. So governments around the world, but also here in Scotland, care deeply about fixing this problem. And one of the things that's been identified is a particular type of pollutant called fine particulate matter. And these come in 2 different types, and they are determined based on their size. And particulate matter are really small objects, really small pieces of dust that are in the air that we breathe in and out. And you can imagine that these going through your lungs is not particularly good for the human body. And so as much as possible, they are trying their best to reduce the amount of these that exist in the air. And these can be caused by any number of sources of pollution. And so one of the things that the Scottish Government has done has identified 38 areas around the country which have been titled air quality management areas. Some of these are just streets within a city, some of these are wider regions, but these air quality management areas exist as areas of high concern which the government wants to monitor and focus on. And the way that these were determined was using statistical modelling. Using statistics, they identified, well, where are the highest rates of these pollutants? And then we also now use statistics to model, well, how much has the level of these decreased over time? So let's take a step back and think about where statistics is actually being used here. When I say statistics is being used, what do I mean by that? Well, across Scotland, there are 99 monitoring stations which have been set up specifically to identify and monitor air quality on a number of pollutants, including the fine particulate matter, which I just spoke about. And you may have seen, if you live in a city in particular, you may have seen some of these monitoring stations every day. You may have walked past them and you might not even have known about it. But these monitoring stations collect data daily, hourly, about how much air pollution is in the air at all of these sites. And this is the main building block that's used by the government to help them understand how polluted our cities are, how polluted our towns are across Scotland. You may be thinking, how do they decide where to put these 99 stations? Do you spread them equally across the country? Or do you put them in certain locations where there are more likely to be pollution? And indeed, the latter tends to be the best way to do things. If we know that, for example, the wilderness of the Scottish Highlands is not going to be particularly polluted, it would be a bit of a waste to put a monitoring station there, because we wouldn't need necessarily to know that we have low pollution in those areas. Where we want to focus our energies and where the monitoring stations go are in busy cities and in towns, and also around about areas such as factories and airports, which are known to be highly polluted. But the decision about exactly where to put these stations involves statistics, involves optimization, which is a key skill that you will learn as part of a statistics degree. After we have those 99 monitoring stations in location, we also might be wondering what to actually do with the data. We have a lot of it. So we have to think about, well, how do we model the pollution rates at the same site over time? And also, how do we use just 99 locations to actually get a full picture of all of Scotland? Statistics is all about filling in the gaps. It's all about taking the data that we do have to help us learn about things that we don't know about. So we have to understand that even when we have the world's best monitoring equipment, it's still got a little bit of error in terms of how it's measured. If you imagine measuring something with a ruler, you're going to get it right to within the nearest centimetre, but you may be a little bit off beyond that. It's the same with all equipment. And statistics also has to understand how wrong we are. We have to understand that we are wrong, and we have to know to what extent are we wrong. And that is a big part of what we're doing in our subject. And so specifically when we're using these monitoring stations to think about the pollution across Scotland, what we have to do is take the monitoring stations which we do have, and you can think about this as having a big map and putting a point where each of the stations are and saying, well, we know within a reasonable degree of certainty that the pollution level here is a certain number. And then we have to try to think about, given all these numbers that we have on the map, how do we estimate what the number will be at a point in between those? So in terms of filling in these gaps, we can start to use kind of our common sense, essentially, as to give us a guide as to what statistics will really do. Suppose we only had 2 points. Suppose that we had the air pollution at one end of a city and the other end of a city. If one end was 30 and the other end was 50, and we wanted to estimate what the pollution level was slap bang in the middle of the city, naturally, if I asked you that question without thinking about statistics, without even thinking that you knew anything about statistics, you would probably tell me that you think the number might be around about 40. It's the average of 30 and 50. It's the number right in the middle. If I was giving you a point nearer one side of the city, say nearer the side that was measured as 30, you might start to think that the estimate was closer to 30 than it was to 50, because you're trying to think about a straight line between those 2 points, and you're assuming naturally that the pollution level would increase between the 2 points based on the information you have. But what we do in statistics is essentially just a bigger, fancier version of that. We take all of the information from all of the monitoring stations, and we start to use that information using what is called in statistics a model, but really just a mathematical equation to estimate the pollution level at any one of those points on the map. And throughout your degree in statistics, you will learn lots of different ways to model data and lots of different ways to understand how we can use the information we have, and also our knowledge about how the data have been collected to help us make the best quality estimate. And also the crucial thing about statistics is we are also not afraid to say that we don't know. And statistics is all about uncertainty. So as well as being able to give an estimate of the true value that we think is in there, we're also going to be able to say, but this is just an estimate and we think that there is this amount of uncertainty about that. So we can start to put a probability, a number on how confident we are in our estimate. And that is how the Scottish Government monitors air quality across the country. Some of my colleagues, statisticians at the University of Glasgow, were actually involved in setting up the low emission zone within the city of Glasgow, which was specifically geared at bringing down the amount of pollution in the city. That was driven by statistical data, by the sort of modelling that I've described. And similar projects are going on throughout the university on a number of topics relating to air quality. And statisticians and statistics are at the forefront of that, because we have to use the data, we have to use the knowledge we have to help us understand pollution. But air quality is not even the only environmental topic that we cover. Statisticians from the University of Glasgow, colleagues of mine, are currently doing work on monitoring water quality using very similar techniques, understanding the levels of pollution in water around the country, understanding river networks and how they flow together, and also understanding biodiversity around Scotland. There's been a lot of talk recently about rewilding species into Scotland, and statistical modelling could play a key part in understanding the impacts that this could have on Scottish wildlife. All of these topics are part of a module which I teach called Environmental Statistics at the University of Glasgow. But as well as that, there are many other courses and many other interesting topics that are covered by statisticians. We also work within the department on health statistics, understanding disease and understanding how diseases are unequal across Scotland and across Glasgow. delving into inequality, understanding the reasons for that inequality. We also have a lot of work in finance. Statisticians are well liked by the finance industry, and there's always opportunities to go and work in that area once you've developed the skills from your degree. And statistics is also playing a big part in the recent push towards developing AI. And that's another thing which, as part of your degree, you'll be able to understand a great deal. Hopefully what you've learned today is that doing a statistics degree at the University of Glasgow gives you a wide degree of opportunities to really be involved in a subject which is ever growing and which has real tangible opportunities to change the world.